Hi, mining community. Welcome back to another episode of the Dig Deep, the Mining Podcast. And today's guest is Clem Rowe, who's the Managing Director at IPI Packers International Limited, who are a leading designer and manufacturer of downhole products with distinctively different inflatable packer technology. These inflatable packers can be used in mining for rock burst migration, block caving hydrofracture, remote or deep permeability testing, rock stress testing, and also custom-made solutions to fit your requirements. Clem has over 30 years in the design and manufacture of inflatable packers. So he's here today on the podcast to tell us more about these products and how they can benefit the mining industry. So that's welcome, Clem, to the podcast. How you doing, Clem?
Yeah, good, Rob. Thanks for the introduction.
Yeah. And appreciate you taking the time to come onto the podcast. So, as I mentioned, you've been in the industry for a long time. So, I wondered if you can give us, an overview of your career, and then obviously tell us a little bit about IPI Packers.
Okay, for sure. My entry into mining really has been via a strange route in that. I didn't really have much to do with mining at all, even though I was born and bred in a mining centre in Perth, Western Australia. My profession is, I'm a mechanical engineer by profession, and I started off my working career working in offshore construction. That's construction for offshore platforms, basically. And that eventually led me to offshore foundation drilling, which is drilling for offshore foundations, as it sounds like. And I got involved in doing some of that, or actually remedial work on some foundations offshore at the northwest coast of Australia. And I got involved there with a local inflatable packer manufacturer for injection of an epoxy cement, basically, to strengthen the formation there. And when that project finished, the guy who owned that company offered me a job, and I thought, oh, well, this is something more interesting than what I had lined up, which was probably, work back to an engineering consultancy and tender on some projects and hope something came up. So I jumped ship there and joined that small company. It was a very small company at the time. It was only about, I think probably I was the 10th employee. So that was how I got involved with inflatable packers. And because inflatable packers are used in the mining industry, I started to take an interest in mining locally. And started learning more about it as I was learning about inflatable packers. Also, in that position, I had the opportunity to do a lot of development work to improve the types of tools that were manufactured with inflatable packers, including inflatable packers, and I found it very interesting. The owner of that company was a guy who really didn't want to do anything outside of Australia. He didn't trust export. He was worried about his ideas being stolen, his designs being stolen, and things like that. So after about 12 years working there, I finally summoned up the courage to talk to him about starting an independent company that was going to be focused on export, on the international market. And that's really where IPI started off from. Inflatable packers, I mean, I don't know, I hope that your audience understands what an inflatable packer is. They're not a very common, I guess, product that you're going to find on, most drilling sites even. So I think I probably should explain a little bit what an inflatable packer is.
Yes, certainly.
So, well, I think the simplest description, which is very misleading, is a balloon on a stick, which I think first came from our American director, not one that I'm very fond of. And I think a more appropriate description is it's like a short length of hose, a rubber hose, a meter or so long, but when you pressurize it internally, it expands radially. So if you put it in a hole in the ground, that means that when it expands, it will block that hole. And in fact, in the simplest configuration, that's exactly how it's used, as a plug, to plug a hole. This is a very common application, mostly in oil field, less so in mining. but just the packer, the plug is put in the hole, inflated, and it blocks the hole. For most applications though, this expanding hose has a pipe running through the center, and it's sealed at both ends to that pipe, so that when you inflate it, it seals the pipe in the hole. So you can then pump through the pipe in either direction, either into the ground or out of the ground. And the word packer itself, it comes from to pack off, which means to seal. And I think it's probably American in origin. I'm not 100% sure on that, but I imagine it probably is. And it typically refers to the type of seal that we get with the pipe through the middle and the annulus packed off or sealed. And that's the way packers generally work, is that it starts off on the pipe and it inflates outwards to seal an annulus. But in our research, we've discovered that we can also do it the other way, is we can start off outside and inflate inwards to seal on a pipe. So we call that an inward inflating packer, for want of a better term. And these find applications in mining for flow diversion, for very low pressure BOPs, blowout preventers, and also very occasionally for downhole use too. I guess the term packer itself is certainly not limited to only inflatable packers. There's many different sealing technologies which are called packers. Some of your audience would probably be familiar with the K-rubber packers, which are used on sealing a screen into a water well, just a static seal. There's another type called a swellable packer. They're used very, very occasionally in mining, but they find a lot of application in zonal isolation, oil field applications, in oil well completions. And this, in that case, the rubber itself is a rubber which absorbs oil or liquid or water, and in doing so, it swells up. So it's just a piece of rubber stuck on a pipe, usually. When you put it in the environment that it's going to be used in, it swells up and it creates a seal. And then the most common type is a mechanical packer, which is, again, a rubber ring on a pipe, which is compressed axially, which causes it to expand radially, and it makes a seal. Of course, it doesn't move very much because there's nothing to continue it expanding after it's been compressed. Inflatable packers, on the other hand, can expand a long way, up to 3 times their original diameter. In certain cases, even more than 3 times. We have an application where we have a 9-inch packer inflating into a 30-inch pipe, which is more than a 3 times that expansion, and looks pretty impressive too, by the way. If you wanted to see that, you can see it on our website. Inflatables are used less than most of the others, not because of they lack the ability to be used in most cases where the others are used, but because they are more expensive, being more complicated and more difficult to make. They're also more difficult to operate. But in our opinion, they're the most versatile of the many pack-off options available.
Yeah.
The other thing about inflatables that I really should mention is that the ones that we make are not the only type, which complicates things even further. There's probably 5 or 6 different types. The simplest ones are what they call balloon type packers, which are really just a rubber tube, you can make one with a bicycle tube or a car tube, and just band it, strap it to a piece of pipe, and put some air, usually, or nitrogen in there to inflate it, and it'll make a low pressure plug of one sort or another. Occasionally, these things get used for monitoring ones. And then the next step up from that would be a rubber cylinder that's synthetic fabric reinforced. Synthetics could be, nylon or polyester, or for higher pressure cases, you could even have Kevlar or carbon fiber reinforcement. And that's getting towards being a serious inflatable packer in our view.
Yeah.
There's also the hose type of inflatable packers, and these are manufactured on a machine. They're steel wire reinforced, and they're very common in low pressure grouting applications, in construction and other similar applications. Oil field, not oil field, water well and mining use them as well, but not as extensively. The other type, or one of the other types of woven steel wire reinforced packer, uses a woven steel reinforcement, so that it's like a braided steel, if you like, It's braided around an inner tube, which is a separate inner tube. It's not bonded to it. So you have an inner tube that's separate, a woven carcass of steel reinforcement, and on top of that you have a rubber cover, again often separate. And this construction was originated in the oil field, and it does offer a very competent high pressure packer. It's mostly been superseded now by a different type, which is still a separate inner tube and a separate cover, but instead of the woven steel wire, they're using steel slats these days, which is like, imagine Venetian blind slats, but very high tensile steel. They overlap each other and wrap around axially around a cylinder, so that when the cylinder inflates, the slats sort of slide one across the other as they to open up. They're very good for high expansion, for high temperature, but they have their limitations as well. And then there's our sort, which we champion in every environment we can. Ours are contra-wound steel wire reinforced, and they're a full composite. The inner tube, the reinforcement, and the cover is a full rubber composite. So all vulcanized together, which makes them very, very robust. And as I said, we're doing our best to prove that they're the best high performance choice in all applications.
Yeah. Obviously, you mentioned about all the different types of packers there. What examples can you give where your packers are used by the mining industry? So it just wanted to give us some examples, so some of our listeners who may not be using packers but may feel, oh, that could actually help us. I wondered if you can just give us some examples.
Sure. There's fortunately many examples of where inflatables are used in the mining industry. I'll just give you a list of a few, which is like hydraulic fracturing, which is, I think, quite a well-known one, at least the term. Permeability testing, solution mining, which is a growing one, high-pressure grouting, especially for curtain grouting, and there's several applications around water wells. If I can just give a little bit more detail on each of those, but starting with hydraulic fracturing, because that's often elicits a quite emotional response from people these days because of the very bad press that hydraulic fracturing has got from the oil and gas industry.
Yeah.
The entire environmental movement seems to be against it. And I won't comment on that any further, other than to say I'm happy that the variety of hydraulic fracturing used in mining has very little to do with that variety, and certainly has none of the potential environmental impact that I'm aware of anyhow. Underground mining uses hydraulic fracturing for two main applications. One is in mine planning stages, and the other is in production. The one used in mine planning is what they call stress testing. Stress testing, what they're trying to work out is what the in situ stress field is in the rock that they intend to go ahead and mine, because that will have a big bearing on what sort of supports they need in the mine, and even the directions in which they actually arrange the mine. So one of the ways that you can work out what the in situ stress is drill a small diameter hole, install an inflatable packer, a straddle configuration, which is basically two packers, a double packer. Inflate the packers and then pump water in between them to a very high pressure to create a fracture. And the pressure at which that fracture opens tells you, one, something about the rock strength, and two, something about the stress field in that rock. In fact, the least principal stress is the one they're looking for with this. It's because it will break along that line. And then once you've created a break, you can open and close the break to better characterize the ground. You could also install what we call an impression packer into that fracture and take an impression of it along with a downhole compass, so that you can determine not only the strength of the rock and the direction and the in situ stress, but also the direction of the stress field from the direction of the fracture. So that's one of probably the early ways that hydraulic fracturing has been used in mining, and it's still used a lot in that application. They tend to be smaller holes drilled from underground rather than the larger diameter ones that are used for some of the other applications. And principal among the other application is one called used for block caving. It's preconditioning, preconditioning of the rock mass for block caving. By preconditioning, what they're trying to do is break up the rock mass. So that, I don't know if you're familiar with block caving, but block caving is basically a mining method where they go in underneath the ore body with a access tunnels, and then they drop the ore body down into there, muck the ore out, and mine it out that way. Now, sometimes that's great if the ore body is supposed to fall down under gravity, but if it's too competent, it won't fall down into the hole. So you can precondition it, pre-fracture it using hydraulic fracturing. In this case, what they do is they drill a pattern of holes up into the ore body, and they'll then install inflatable packers into each of these boreholes, one at a time, and fracture, say, every 1, 2, or 3 meters as they come down the hole, if they're going up hole, or from the bottom up if they're going down hole, in an effort to break up the ground, basically, so that it will flow properly afterwards. Now, one of the other possibilities with hydrofracturing, it's sort of a little controversial as to how well it works or not at this stage, but it's certainly being investigated very thoroughly and implemented in some cases in some mines. And that's to use hydraulic fracturing in very much the same way as for the preconditioning. But in this case, what they're trying to do is redirect the rock stress to relieve the rock stress to guard against rock burst. As you're probably aware, rock burst is a very dangerous phenomenon which can occur in deep underground mines because of the high stress in the rock. And it certainly has been responsible for the death of many miners. So this is a very promising technique, which is being, as I said, investigated and being implemented as a routine measure in some places. It's going to become more and more common, I think, as mines get deeper and deeper, which they're certainly doing.
Yeah. Obviously, you mentioned hydraulic fracturing. How is that obviously used in mining, and how does it differ from obviously oil and gas?
Well, the main uses in mining are the ones I've just described. In oil and gas, the biggest difference is really the volume of fluid that's pumped in. In the biggest volume of highest flow rates that you likely to ever see in a preconditioning fracture is probably around 300, 400, 500 liters a minute, and that'll be pumped for maybe 20, 30 minutes, that sort of thing. And what they're doing there is they're opening a fracture, and then they're using that flow rate to propagate the fracture. They're pushing the fracture out to make it longer and longer, so they break up more and more of the rock.
Got it.
In shale oil and gas, tight oil and gas, what they're doing is exactly the same process, and the pressures there are much lower for most cases because their rocks are lower and their stresses are lower. They don't have tectonic stresses to deal with for most cases, so their pressure is lower, but their flow rates are ridiculously high. I don't know if you've noticed, but if you see a frac job, pictures of a frac job for oil field one, you'll see a whole bunch of trucks, big pump trucks lined up. So they'll be pumping, whereas you'd only have one of those for underground hydraulic fracturing for a mining application. For an oil field application, you might have 20 of them. So they're pumping for much longer. They're also pumping, in most cases, they're pumping proppant, which is typically sand, to hold the fracture open afterwards, which they need to do because they want to produce through there. Whereas we're not looking to produce, we just want to break the ground up. So that would be the main difference, I guess.
Yeah. You mentioned permeability testing. I wonder if you can just explain a little bit more detail around that, and obviously it being a major use in the mining industry.
Sure, and it is probably the largest use of inflatable packers in the mining industry, and probably the only exposure many drillers will ever have to inflatable packers. In fact, in the mining industry, they call it packer testing. And what it is it's normally associated with a wireline coring exploration program, where they're wanting to include a hydrogeological investigation alongside their exploration drilling. In this case, there's a packer system available that after they've cored a certain section of the hole, they can pull the core barrel out on a wire line and then run a packer system in there, inflate the packer, and do a permeability test. And that's just pumping water into the ground under a specific pressure for a specific period of time and checking how much water, how much flow, how much pressure, that sort of thing. That's a very simple test. Now, what we did was we developed a system. These tests have been around for, like, let me think, I don't know, since the 60s, I would imagine. 1960s, that is. I have to clarify these things now. So, yeah, these tests have been around a long time, and they were always using gas-inflated packers. Now, packers can be inflated with gas with a separate inflation line, but you're very limited to the depths you can run with that sort of system, because the gas pressures very quickly become very high, because you need enough gas pressure to expand a packer that's underwater. And if your hole's 300 meters deep, well, that means you need 30 bar of pressure just to start expanding it. If you want to then test at another 30 bar, you need 60 bar of pressure in the packer. And that's starting to get up there in terms of how much gas pressure you might have available on surface. So we looked at that and thought, well, there's got to be a better way. And we came up with what we call SWIPs, which is we like to call it a standard wireline inflatable packer system. And it basically uses water to inflate the packer instead of gas. And we don't have a separate inflation line. We use the drill pipe to inflate the packers via a system of valves. And we use the drill pipe again to we actually either use the drill pipe to deflate or the wire line to deflate. We have those options. And we introduced this product initially in about 2005, I believe, as a standard product. It was our very first standard product. And we launched it, with something very new for us in those days, was a marketing package and everything like this. And it had its first runs in this configuration, even though we had some trial runs in New Zealand prior to this with a New Zealand company. But after the launch of the product, its first runs were in Papua New Guinea, and we didn't get off to a great start. I was actually on that job. And when I turned my back after we'd done the first test, the driller had decided it was time to retrieve the packer. So he just hauled on it. We got half of it back. So after a little bit of training, and we subsequently got some pretty good testing done there. And we came to the notice of a Canadian hydrogeology consultancy company. And they saw its potential, and really they pushed worldwide for us through all of their different divisions. And to the extent that nowadays SWIPs is probably the tool of choice in, well, let's say all but the shallowest of mine hydrogeology investigations these days. And it's used all over the world. It's certainly our most popular and widest selling product. And we have, after we got SWIPs up and running, we did develop a second generation, which is a more sophisticated tool, which we call STX. And it's able to do a lot more complicated, sophisticated testing, because it has different features, such as a downhole shut-in capability. But SWIPs is still holding its own. STX, of course, is being more complicated, is also more expensive. That may have something to do with that story as well. But,
yeah. You seem an innovative company. Does innovation play a big part in IPI's developments?
It sure does. In fact, it's been at the core of our development ever since the get-go. I'm, as I said before, an engineer by profession. I've always loved working with mechanisms and trying to, ferret out better ways of doing things with different tools. And the whole technology of inflatable packers, and the thing that attracted me to it in the first place, is that it's really a wonderful playground for someone like me, because it gives you a very flexible, a very versatile base technology that you can apply to many different applications. And when I first started IPI, we started really as a custom innovator. People would come to us with their real world problems, and we'd work out how to solve them using an inflatable packer. In fact, one of our very first permeability testing tools was for a tunnel investigation, a big underground tunnel in the Alps. And this tool, when the customer came to us, they wanted a tool that they could pump down up to 1,500 meters into a horizontal section of the investigation hole, do a permeability test, which is pumping in. They wanted to be able to pump in and also to extract fluid. And they also, after they'd finished extracting, they wanted to take a sample of the natural fluids they'd extracted. So it was a pretty big ask, but we did manage to work out a design, and following some, teething problems, of course, you always expect with a new design, we managed to produce a tool that did the job. And in fact, that was the forerunner for the SWIPS tool that I discussed earlier. SWIPS was a much dumbed down version of that, but that was the basic, gave us the basic idea for the SWIPS. We've continued to innovate ever since. I mean, every product we produce is in some way an innovation. We're not great on copying other people. We don't think that's a great way to get forward and get ahead in the world. We like to do things our own way. And we put a lot of effort into not only into the developing new products, but also into understanding the actual physics behind inflatable packers. Because inflatable packers are a combination, well, our style anyhow, it's a combination of steel wire and rubber. So it's a rubber composite. And rubber is one of those peculiar materials. It's hyperelastic. It has very poorly understood properties in the most part. And only an empirical knowledge of how it behaves, the actual, let's say the fundamental physics of how rubber behaves is still not very well understood. So what we've done for our particular product is we've taken both an analytical approach, where we worked with a university mathematics professor of all things to try and develop a model of how these things work. And then we've also in-house, through our own research and development department, we've developed a digital approach using finite element analysis. Now, these things have allowed us to develop a software package that we think is pretty unique in the industry, and I'm talking across the whole industry, including oil field now. That this software package enables us to predict with a high level of confidence exactly how a new design will work in terms of what expansion pressure we will get from it, what will be its burst pressure, for example, and how we can use it, how far we can push it, what temperatures we can run it at. In fact, bringing temperature into it reminds me of another thing. We had to develop a laboratory in Perth to investigate the rubber, the elastomers we were using, not just under ambient temperature, but at higher temperatures, because deep mining running pretty high temperatures these days. We have application in Indonesia, which is up over 100 degrees C for mining. And in oil field, it's quite normal to run those applications above 100 C, and typically the customers want above 150 C, but that's a little bit harder. But in order to investigate the capabilities or extend the capabilities of our product, we need to develop this whole laboratory, which not only looks at the physical characteristics, but also the chemical characteristics and how our rubber responds to different chemical environments. So it's very demanding, but very satisfying actually to develop new products in that way.
Yeah. How do you use inflatable packers sort of benefit the tunneling and grouting? You mentioned obviously tunneling and grouting previously. Just wondering how these packers, how they actually benefit those areas.
Sure. It's kind of interesting, again, as I hark back to the very beginning of IPI, and one of the very first applications when I was working by myself, by the way, was to do a high pressure packer for a grouting application, again in New Zealand. There was an underground mine there, a deep coal mine, I believe it was, that intersected a water zone, a high pressure water zone, and they needed to inject pressure into this zone to seal it off. So what they had was core holes with water gushing out of them under high pressure. They needed some way of sealing it, plugging it, and then pumping cement in there. So we came up with an inflatable packer that they could push up to these holes with the center pipe open, so the water could continue to come out, so they were able to push it in the hole. And then they inflate it, which would anchor it in the hole, and then they could pump cement through there. So this is one way that we've probably the original way that we started working with offering a solution for high pressure grouting in these water control applications. Now, more recently, very recently, in fact, we've come up with something that we call the expandable standpipe, which uses an inflatable packer to expand a thin wall steel tube that has a rubber cover on the outside. Now this, which basically when the steel pipe is expanded into a hole, it gives you a standpipe, which you didn't have to cement in there to have the standpipe. You just put it in the hole. You can put it in a hole where the water's flowing out, or you can put it in a hole before you drill into those high pressure zones, which is preferable, by the way. And in those circumstances, you can use the standpipe as you would any other standpipe to pump cement into the formation to create a waterproof zone for curtain grouting, in other words. And that's applicable in mining, which is where we've developed it actually for mining, but it's certainly applicable for tunneling too. In fact, we think it's got a lot of legs, this product, to the extent that we've done something for us extraordinary, and we've applied for a patent on the design, which hopefully it all turns out well. Don't have a hell of a lot of experience with patents, but we have a few, and we think this one's worth it. We hope so anyhow. We hope to hear a lot more about it as it becomes more widely adopted.
Yes, certainly. You also have applications in solution mining and for water wells. I wonder if you can just give us an overview of that.
Sure. Well, solution mining, as you're probably aware, other than for uranium deposits, which have been mined with solution mining techniques for a long time, it's really a new technique that they're trying very hard. There's a lot of research going on at the moment on hard rock mining, hard rock ores being mined with solution mining, trying different lixiviants and different mining techniques. And we know for a fact, because we're involved in some of this research and some of these early stage adoption of these techniques, we know for a fact that that they will use inflatable packers in these applications. And we're hopeful, of course, that this becomes a more common mining method. And I believe it will, because of environmentally, it looks very good. I mean, it doesn't disturb the surface to anywhere near the extent that traditional mining techniques does. And that's got to be a good thing. As far as water well, started off actually when I first went international with IPI. I thought I was going to take the world by storm with water well products, because the company that I had worked for, where I had developed all of these products, had quite a swag of different water well techniques that had been well accepted in Australia and had quite a history of use in Australia. What I discovered pretty quickly when I got out in the big wide world was that there wasn't much call for it, because what was valued in Australia was not valued as then elsewhere, in terms of people weren't prepared to pay that much money for something they could do with other cheaper, easier ways, as far as they were concerned. So water well never went very far in the initial days, but these days there is a lot more applications, and we do everything from pump installations, well installations, to multi-level sampling systems, all around water wells, basically. I won't go into all the different possibilities, because there's many. People are interested, again, the website's full of it. So.
Yeah, certainly. Obviously, one question I didn't ask, which I should have asked probably at the beginning, is I just wondering if you can give us, obviously, IPI is international. Where are you based, and what countries do you cover, and where do you have your offices? Because I believe you're all over the world. And sort of how many people work for that particular division?
Sure. Yeah, well, as you said, we're all over the world now. We started in Perth, which is my hometown, Perth, Western Australia. And we've grown from there. Perth is still our major production. In fact, at this very moment, it's our only source of production, our only factory, and it's our major employer. We have in the region of 60 people employed in the Perth factory at the moment. Other locations are Montana in the US, which is basically a sales and service with some warehousing. We have here where I am, I'm actually based in Bulgaria. We have a sales office for Europe in Bulgaria. It used to be our only sales office here, but we've recently, since we've started doing more oil field, we've opened an office in Amsterdam, which looks after oil field basically for Europe. And we've also opened an office in Houston. And we've shifted our head office to Singapore. So basically marketing, accounting, those sort of head office functions are done out of Singapore these days. Perth remains the factory, if you like. But we are also developing a factory just started developing a factory in Bulgaria. We think that's more for that for the future, though, for sure.
Yeah, certainly. Yeah, and I was going to say, as a conclusion, I wonder if you can give us an overview of the next, I suppose, 18 to 24 months of IPI, what you're looking to do, and how you're moving the company forward.
Okay. Well, 18 to 20 months to, 12 to 18 months is probably pretty clear and pretty exciting too, because at the moment we're just completing construction of a brand new premises in Perth, which are 50% bigger than where we're presently located, and much better organised than our present location, I think. We're expecting to move in there October, in fact. The building is getting very close to completion. And it's interesting and a little bit daunting. As we started this project in Perth, we bought the land in 2019, and we're just finishing the building now at the end of 2021. And in that period of time, even with COVID, our business has actually doubled in size in terms of turnover. So we thought we'd move into new premises with plenty of space. Looks like we're going to be fully utilised when we move in. So our rubber works, we're also doing some other things in Perth. Our rubber works there is clearly very important because of what we do, but also we're heavily reliant on our machine shop, because not just do we do the inflatable part of tools, we do the entire tool for the most part. And our machine shop already includes 5 CNC lathes, all very modern ones. When we move into the new shop, we're going to be buying another couple of very large ones, and also we'll be marrying them up with some robotic systems, hopefully to improve our productivity, which is, as I said, we're expecting to be fully utilised in the new building, and we're going to need that extra productivity going forward. The way things are recovering at the moment, I think that will hopefully that will be needed. And as I also mentioned before, we're looking at a new manufacturing location in Bulgaria. It's in regional Bulgaria. It gives us access to a central location in terms of supply to and from Europe and for the Middle East. And it also gives us access to, here in Bulgaria, a well-educated and yet very affordable workforce, which enables us to enter markets that traditionally we haven't been able to because of our high costs when we're manufacturing in Perth. Perth is a wonderful place, but it's very remote, and it's an expensive place to manufacture, employ people to do everything, even buying materials, everything. And the guy who's establishing the factory here, Dave Nell, who's a shareholder and a director, good friend of mine, has been actually my first employee at IPI. And he's here with me in Bulgaria. He's setting up that operation right now as we speak.
Okay.
Not oil field, but as I said, we've opened an office in Houston. I mean, not mining, it's oil field. We've opened an office in Houston, and we're wanting to extend that to basically bring it up to about the same standard as our Montana operation, which would mean that it's able to fully service tools and have some warehousing as well.
Yeah. And I suppose apart from manufacturing these products and then selling the products to, say, the mining industry, I take it you work with clients in terms of actually using the products in the mine.
We do. We have to tread a very careful line there, because most of our customers are in fact service companies. They'll be consultants or drillers or straight out service companies. So we can't be seen to be competing with them. So what we prefer to do is we prefer to form partnerships with these companies be it a driller or a straight out or a consultancy or a service company, train their people in how to use our products and support them in using them on site. Now that might be sending people on site for training, could be training them in our factory. It can be just remote support, which is becoming more and more common in these COVID times where you can't travel. So yeah, we've positioned ourselves as a equipment supplier, manufacturer, designer, and on the service side, we offer service where it's needed, and we try very hard not to tread on the toes of our customers in doing so. You know?
Yeah, no, I understand. Clem, really appreciate your time in give us an overview of obviously inflatable packers. And I'm sure a number of our audience would be interested in finding out more about your products and how you can help them. How can they go about doing that? Are you on any social media platforms as well?
We're on LinkedIn and Facebook. You can find us, and certainly the website is always available. There's a lot of information on the website. There's also a lot of animations and videos, which people find useful. It's a quick intro into different aspects of how our equipment works. We may well be putting a copy of this one up there too as an intro.
Yeah, you're certainly more than welcome. And we'll enclose those in the show notes accompanying this podcast anyway. So, and I suppose because as you're speaking, I'm trying to picture how it all goes together. And I suppose by watching some of the videos that you've just mentioned, that will make it a lot easier to identify your product and how it can be used. So I'll certainly be having a look at those videos after this. So I fully understand obviously more about your products. So really appreciate your time, Clem, for doing this episode, and thank you audience for listening, and please share this episode. And until next time, happy mining.